discuss the 2015 Chemistry MCQ paper. Now, I'm discussing this as a help for your 2022 A-level exam. Now you have 2 months more. What you should be doing in these 2 months is this. You got to be doing a lot of papers. Do the papers, and when you get wrong answers, see why you got those wrong answers. Refer your theory notes and clarify those points. Don't always expect a teacher to be teaching everything. The most important thing is self-learning. Now in this series of videos that I'm going to make for you, I'm concentrating on some special questions that have a high probability of coming again, and some chemistry questions that always come repetitively. But it's very mandatory to understand crucial theory points, because those crucial theory points reiterate again and again. So let's discuss some of the important questions for you. Now 2015, let's start. Question number 2. The increasing order of atomic/ionic radii of boron, oxygen, sulfur, sulfide ion, and chlorine. Now you may have learned in your classes about techniques of solving questions. But these issue. Now chemistry is a science subject. Science involves lots of facts. Facts to be understood. So when you're learning science, be very specific. Be on point. Do not go to lots of assumptions. Right? So let's stick to facts and solve this question. Now they're asking the increasing order of atomic or ionic radii of boron, oxygen, sulfur, sulfide ion, and then chlorine. Let's look at the periodic table. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Just represented the first 20 only. Now listen to this theory. You have heard that atomic radius decreases when you go from the left to the right. Atomic radius decreases when you go from the left to the right. Why? Why does the atomic radius decrease when you go from the left to the right? What's the reason for that? When you go from the left to the right, you can see the number of energy levels are the same. Number of energy levels are the same. Now for example, lithium. Just look at lithium. What's the electronic configuration of lithium? 2, 1, because its atomic number is 3. Just take beryllium. What's the electronic configuration of beryllium? What's the electronic configuration of beryllium? 2, 2. 2 belongs to the first energy level, that is called K. 1 belongs to the second energy level, that's called L. So here was about K and L. Just look at somebody far away, that fluorine, 2 and what? 7. Again, 2 belongs to the first energy level K, or number 1, and 7 electrons belong to what? The second energy level, L. So you can see that the number of energy levels are the same. Now, you know, when the number of energy levels increase, what's happening? Atomic radius increases. But now, the number of energy levels are constant. Then what's happening here? We know atomic radius decreases from left to the right, but I asked why? Don't memorize that. Now there should be a reason for that. Why? You can see the number of protons are increasing. Number of protons are increasing. Then what's happening? The nuclear charge is increasing. But remember, more specifically we say atomic radius decreases from left to the right. When you go from the left side to the right side, atomic radius decreases because the effective nuclear charge, what's the word? Effective nuclear charge increases. When the effective nuclear charge increases, atomic radius decreases. Now, why did I use the word effective? Because effective nuclear charge is defined as the nuclear charge minus the shielding effect. Now, can you see when I go from left to the right, what's increasing? Yeah, the nuclear charge is increasing. But number of electrons are also increasing. Therefore, there's a change in what? Shielding effect as well. There's an increase in the shielding effect. But what seems to be the determining factor here is the nuclear charge. When the nuclear charge increases from the left to the right, what's happening? This resultant of nuclear charge minus shielding effect increases. Therefore, effective nuclear charge increases just because the resultant increases. Understand these facts specifically like this. Then we can understand from the left to the right what's happening. Atomic radius decreases because the effective nuclear charge increases. Next point. When you go from, okay, if you consider groups, now these are groups. What are periods? Horizontal rows are periods, yeah, vertical columns are groups. What happens down the group? Down the group, what happens is this. Number of energy levels increase. Now we know when a new energy level is added up, it contributes to what? An increase in the atomic radius. That's a huge factor. Though the nuclear charge increases, the effect of what? Increasing energy levels is more. Therefore, we can say, when you go down the group, energy levels increase, then what happens? Atomic radius increases. Down the group, atomic radius increases. Now just look at lithium. Lithium's electronic configuration is 2,1. What about sodium? What's the electronic configuration of sodium? Sodium's electronic configuration is what? 281. It has gotten a new energy level. In that new energy level, there's one electron. Therefore, what happens is that atomic radius increases greatly when the number of energy levels increase. Now we understood the theory. Now let's look at the question. Now they're asking you to compare boron, oxygen, sulfur, sulfide ion, and chlorine. How can you compare this? I'll erase this part. Some very interesting parts are here. So we have boron, oxygen, sulfur, sulfide ion, and chlorine. How can we compare this? First, refer the elements in the same period. Who do we have? Boron and oxygen belong to the same period. Boron and oxygen belong to the same period, right? Yeah, so we have boron and oxygen. Sulfur and chlorine. Sulfur and chlorine. They also belong to the same period, the third period. Second period, boron and oxygen. Third period, sulfur and chlorine. Let's compare them first, and then we'll compare about anions. Look at this first. Boron and oxygen, they belong to the same period. What's happening? From the left to the right, we know atomic radius decreases. Why? Effective nuclear charge increases. Whose effective nuclear charge is more? Oxygen's. Therefore, the atomic radius of boron is greater than oxygen. Is that clear? Right, so then oxygen has a lower atomic radius than boron. And we know when you go down the group, what happens? The atomic radius increases because number of energy levels have increased. And therefore, whose atomic radius should be higher than oxygen and boron together? Sulfur and chlorine should have high atomic radii than who? Boron and oxygen, because they have extra energy levels. Therefore, these should be having the first variations. Oxygen first, then boron. Now we have to compare sulfur and chlorine. If we compare sulfur and chlorine, what can we say? Effective nuclear charge of chlorine is higher than that of sulfur. Therefore, the atomic radii of whom? Chlorine is less than that of sulfur. So we have chlorine and then sulfur. Now we have to compare sulfur and sulfide ion. Comparing sulfur and sulfide ion, there's a theory. Sulfur as well as the sulfide ion has the same number of protons. Why? Sulfur gains 2 electrons and becomes S2 minus. Therefore, S2 minus has 2 more electrons than sulfur. Therefore, what can we say? Therefore, we can say this. Sulfide ion has a greater atomic radius than that of sulfur. How? How can we say that? Look at this definition. Effective nuclear charge. I write it here. It's clear. Effective nuclear charge is equal to nuclear charge minus shielding effect. Nuclear charge when you're comparing sulfur and sulfide ion. Now listen, I'm writing this equation to compare whom? The atomic radii of sulfur and sulfide ion. When we compare sulfur and sulfide ion, we know that the nuclear charge is the same. Why? They have the same number of protons. Nuclear charge is the same. Why? Same number of protons. Same number of protons. Then what happens? Shielding effect increases. Why does shielding effect increase? Repulsion from electrons increase. Now for example, just look at lithium. Lithium has a nucleus and it has surrounding electrons. It has 2 electrons in the first atom, and then in the second energy level it has another electron. Can you see that this electron can repulse this? So when you repulse, you contribute to increase in atomic radius. Therefore, when the shielding effect increases, what happens? This term increases, shielding effect term increases. Let's say, for example, nuclear charge is 10. For sulfur, the shielding effect is 2. Just imagine. But for sulfide ion, it's not going to be 2. It's going to be a number greater than 2. That means what happens? 10 minus 3 or something. Then earlier for sulfur, effective nuclear charge is like 8. But now what's going to happen? Yeah. For sulfide ion, it's going to be like 7. They're just imaginary values to explain you what I'm saying. So therefore, what can we say? What can we say? Effective nuclear charge for whom? Sulfide ion is less than sulfur. When the effective nuclear charge decreases, when you have the same energy levels, what can we say? Yeah, the atomic radius increases. Therefore, we can say The atomic weight is a sulfide ion is greater than that of sulfur. Shouldn't we have boron here and oxygen here? Yeah. So this is the answer. Because from here to here, what's the thing that is determines? From here to here, what determines is what? Energy levels. Here to here, what determines from oxygen to boron is what? Effective nuclear charge. Here to here is also what? Effective nuclear charge. I hope you understood this.